Thomas is lowering a 2 kg bucket down a well at a constant speed, as shown in the figure below. If something's moving at a constant speed, the acceleration equals 0, total force equals ma, so total force, acceleration 0, total force on it is also 0. Now this is before I've even answered the first question. I know what that means. What's the first question say? What's the total force on the bucket if it's being lowered at a constant speed? 0 newtons. Our next question, calculate the tension in the rope. So we've got the total force equals 0, and that's made up of the actual forces on the bucket. We know that the bucket is 2 kgs, so the gravity force or the weight force must be 20 newtons. And there must be another force pulling it upwards, which for these two to add together to give 0 must be equal and opposite. So this is the gravity force, and this is the tension force. So the tension in the rope is 20 newtons. Our next question is these ones. Alright, after getting to the bottom of the well, the bucket fills with water and is now a total of 6 kgs. By pulling on the rope, Thomas applies 18 newtons of tension force to the bucket. Draw a labelled force diagram for this situation and label it with names and with numbers. Okay, so there's a force downwards, and that's the gravity force. Let's call it the force of gravity, and that equals 6 kgs, which is 60 newtons on Earth. The upwards force is tension, and that's bigger than the downwards one. It's a bigger arrow. The tension force, and that equals 80 newtons. Okay, so I've labelled my diagram with names, tension and gravity, and with numbers. Cool. Calculate the acceleration of the bucket. How do I go from forces to acceleration? I go from forces to acceleration with total force equals ma. Rearrange, I get A equals total force over m. So I divided both sides by m to make A the subject. So I need the total force to this equation. Well, the total force is 80 up and 60 down, so the total force is 20 newtons. 80 minus 60 equals 20. And then divided by the mass of the bucket, which is 6 kgs, we get 3.33 meters per second squared. If the bucket started from the bottom of the well at rest, U equals 0 meters per second, and if the well is 100 meters deep, here's my x, how much time does it take, how much time, question mark, to lift the bucket to the top of the well? So I've got these three, I've also got acceleration equals 3.3. meters per second squared. So what formula has all of these in it? X equals ut plus half at squared. Now the good thing about this is I'm going to have to rearrange it to find t, but u equals 0. 0 times t is 0, so that cancels out. So we're just left with x equals a half at squared, times both sides by 2, 2x equals at squared. Let's go up here. Divide both sides by a, we get 2x over a equals t squared, and square root, we get t equals square root 2x over a, which is 2 times 100 over 3.33, which is 200 divided by 3.333, which is 60, so square root of 60, which I'm not going to do my calculation, I'm just going to hazard a guess, is about 7.8 as a guess. So if I'm wrong, I'm sorry. I think it's about that.